Hello learners, I am Dr. Subodh Kesharwani, working with Indira Gandhi National Open University. The topic which I am going to talk today is types of sampling errors and control. I think we have a very thought-provoking session, somewhere around 3 to 4 sessions, which dedicatedly talk about what exactly the sampling is and how the sampling is quite important when you are going to collect the data and the collection of data. So we have talked about sampling, we have talked about methods of sampling, then we have talked about the random sampling, non-random sampling, and now today we are going to talk about the types of sampling errors, because the moment we go for taking the sample and that sample too is come out from the population, and no doubt certain discrepancies are there are certain errors. So how you are going, and these errors are considered to be statistical errors or sampling errors or margin of errors or the different kinds of errors. So today discussion revolves around what are the types of sampling and non-sampling errors and how we are going to come out from that, because while talking about the sampling, while talking about collection of data, there are certain errors which is a routine matter, which is a routine issue. So no need to worry about it, but how you are going to come out from it, that is more important. So today's discussion, this particular discussion, talks about how we are going to come out from the sampling errors and how we are going to find out the sampling errors. So anyway, the very first thing that talks about the collection errors. And if you talk about this collection error, I think when we are going to collect the data, when we are going to collect particular when you are going to float the samples, I think we have to quite cautious that from where we are going to collect the data. If the data collection is wrong, I think the input is wrong, the output is no doubt different from there. So there must be certain respondents to whom you are going to cater, and how you are going to cater, that is more important. So if you are going to cater a wrong respondents, I think you get a wrong results. So if you see this particular image, I think there are certain things which are linked with the female members, but the male supposed to be considered as a respondent. So what is happening, that in that case the data which we are going to get is going to give the wrong information. So wrong results will come as wrong input taken. So in computers, in data, we usually call about garbage in garbage out model, which says that whatever the input is there, the output is going to be based on the basis of that. So the very first the statistical error or the sampling error which comes comes through the collection error. So one has to quite cautious while going and finding out the collection errors, and then what are the causes that cause the the sampling error or the statistical error. We are definitely going to talk about that also. And one thing which is very important as far as the research is concerned, that though we go through n number of literatures, the literature review process is going on, and we have reviewed numerous literatures. So from there the certain expertise need to be developed, but as a researcher it is our moral duty that we are not going to conclude on the basis of our the knowledge bank, but we should see what exactly the respondent used to reciprocate. So on the basis of the respondent's reciprocation, we try to make the opinion and then come to the conclusion. So if you see this particular image, it talks about that I think we have to take a sample, because and the individualistic approach is quite different from the holistic approach or from the masses approach. So this is all about, this is a particular course which we usually talk about research methodology and statistical analysis. We have almost 12 to 15 lectures right now, and we are in the unit 4, that is sample, and on the verge of completing this unit 4. And this is part of the first block, that is research and data collections. And you see that we have another 4 or 5 blocks which talks about processing and preservation of data, then relational and trend analysis, then probability and hypothesis testing. Hypothesis we have elaborately talked about in this particular session, but as far as the collection of data is concerned, we have a full-fledged session talks about the hypothesis, but we have not tested the hypothesis. So when we are going into or little bit mature as far as the discussion is concerned, then we will definitely talk about how to test the hypothesis. So this could be part of the 4th block, and the 5th block talks about interpretation and reporting. So as far as the basic part is concerned, we have covered the research part, we have covered the research method, then research sampling, then random sampling, then formulation of objectives, hypotheses, research design, collection of data, and sampling. So in the preceding session we have talked about the random sampling and non-random sampling. So this is one of the two methods by which you are going to do the sampling. And if you talk about the random sampling, it talk about stratified sampling, it talks about the cluster sampling, whereas when you talk about the non-random sampling, it's quite purposive in nature, and it revolves around the judgmental sampling or the convenience sampling. So but again certain biasness is there, and that leads to error. So the today discussion talks about how this sampling and non-sampling error is going to be viewed and or going to be explored and then rectified at certain stage. So we have already talked about the sampling, we have talked about the methods of sampling. Now sample size, we have covered what could be the sample size, and there are certain thumb rules which talks about that this could be your population, this could be your sample, and your sample size could be from all the jurisdictions of the population. It's not like that you can bifurcate the population into 4 segments, that is north, south, east and west, and then just concentrate on one of the zones. So if you are concentrating on one zone, I think your result is going to be quite biased in nature. So that is where the discussion was going on, and today we are going to talk about how this sampling and non-sampling error is going to be taken care, and how we are going to control those errors and how to come out from the errors. So that is more important. So prior to going into the depth of this, let's throw a light on what exactly the sampling error is. Why does sampling error occur? Because when we do anything, when we commit any sample, because sample is nothing but there is a big circle which is considered to be a population, and there is small circle considered to be a sample. If you see this particular circle, I think we have taken a holistic view, and we try to collect the sample not from one side of the population but from the different sides. So from this north side, from the bottom of the circle or from the mid of the circle. So you find out that different samples drawn from the same population can have different properties. That is very true, because if we talk about the example of a Delhi, and if somebody had done a research of the Delhi consumers, and if they are just catered to the North Delhi consumers and then take the data from the South Delhi consumers, I think the mindset is different, the approach is different, and the buying perception is different. So in that case you will find out the different kind of result is going to come, and this is quite deviated from the other zones, and somewhere you find out that this is going to give the very different opinion, and when you are going to accumulate, I think somewhat the result is going to vary. And this is the reason certain outliers are come, because you are not familiar with what could be the result. So these are the certain things which can generate the phenomena called sampling errors. And when you take sample from population, you only have a subset of the population. That is very true, because again if you see the size of the circle is quite bigger, but as far as the collection of sample is concerned, this is quite minute in nature, it's very small, it's very petty in nature. So you have collected the information which is just a glimpse of that, which is just a small portion of that, so a piece of what you are trying to understand. So that is very true, because it's really cumbersome for the researchers to go into the depth of the population and or the universe to collect the data. So that is the reason from various aspects the sample is going to taken, and we try to come out to the conclusion what could be the impression of that. So this is purpose behind that, and that is very true. Once you are taking a sample, there may be a possibility that whatever you have taken may be not match with the population characteristics, and somewhere you find out certain deviation is there. These deviation are considered to be the sampling error. So we will definitely throw a light on what exactly the model is there. And if we are going to study about the random sampling and non-random sampling for choosing sample, I think as far as the sampling error is caused by way you choose your sample, we have seen that in non-random sampling that we believe in convenience sampling or volunteer sampling. So these are the model which somewhere quite biased in nature and causes bias. So somewhere the error is going to come up, because you are quite convenient as far as the collection of the sample is concerned, and you try to make the population as per your convenience, and that is the reason the results used to come, it's quite deviated in nature or maybe not holistic in nature. So how do you reduce? That is more important. So reduction can be done when you are going to use the randomness in choosing your sample, and if you are going to be use the randomness in choosing the sample, I think somewhere you get a very different kind of results which can give a different report and may be quite varied in nature. So anyway, if you talk about the sampling errors, I think we have a very elaborative sessions in the past when we are going to talk about the sample, starting from the preamble part of sample, then when we were talking about the methods of sampling, either it could be non-random sampling or random sampling or probability sampling or non-probability sampling. We have seen that the whole thing starts with the population. If you see the outer circle talks about the population, and then when we get the population, when we earmarked ourselves that now this could be our population, then we frame the sampling format. And if you see, and that no doubt it could be somewhat revolves around the population or maybe somewhat the inner circle of the population. So we have seen that we started with the with population, and then we have made the sample framework, and then from this sample framework we realize that now our jurisdiction is that only, and when we have make the sample framework, now the whole things revolves around this particular circle only. So then in this sample frame we have make the pedagogy of collecting the sample, and this sampling could be now we have observed that when we have gone for sampling, I think the response comes, because when you make the sample, when you have developed the questionnaire, you float it to the respondents, and when respondents reciprocates, sometimes the response used to come what you are expecting, that your sample is this only, but the response used to come this only. So there are certain gaps. These gaps are considered to be a response error, because you are not getting any intimation, any information from this particular model, particular the gap. So these fillers are considered to be the response error, and the difference between the sampling frame and the sampling is considered to be chance error, because when you are going to talk about the chance error is like so that you are not getting an opportunity to find out, but again there is a scope of the collection of the data. Then frame error is there. So still why you have taken this particular sample, why you have ignored this much the filler which is there. So what I mean to say, when you are going, because there as a researcher there are certain constraints which is very important, and that constraint is that you are not in a position to explore the total population. If you are going to explore the total population, time is quite consuming in nature, and your effort is very high, the cost is going to be very high. So, and again it's really a cumbersome, because if you cater the whole population, I think then there is no use of going and talking about the sampling. The sampling itself talks about, as I have previously mentioned, that when you are having a big basket, or the big basket of rice, from there you extract some of the product, and you check it, and by checking that particular product on a random basis from all the areas of that bag, you realize that whatever the product is coming is quite similar in nature, and the results are quite same in nature. It means that the results you have achieved is going to give the total impression of the whole bag. So this is basically a beauty of the sampling. It's not like that due to the sampling errors or statistical errors we are not going to apply the sample, but we will concentrate on the population. It's really cumbersome, because if somebody had done a research on Indian consumers, or if somebody had done a research on the learners studying in different universities, I think you have to earmark certain states, then certain institutions, then you have to explore the research. If you are just talking about that, you can just cater the particular universities or the particular state, so that considered to be a bias approach. So that could be the model which is there. And when you are going to talk about the sampling errors, I think the sampling errors is talking about errors of representation, and that is very true, because it's good that the sampling error is coming, which can give you work as an alarm bell and make you alert that now you have to deviate. You have to deviate your sample plan, you have to deviate your sample strategy, and then the model need to be done. So we start with the target population. We see that what exactly the target population, who you want to ask. So this could be the target population. And it's not like that once you earmark the population or universe, you just concentrate on that. So anyway, now the coverage error is there. So we have seen in our previous the slide that how the sampling frame is because after targeting the population, the first thing which comes up is the making the framework. that this could be a sample framework and you are going to confine yourself on this particular domain. Like, let's take example, if somebody is doing the research on Delhi, I think the target population is now Delhi, but so what exactly your zones, 4 jurisdictions now. It's now again you have to make certain strategy, you have to make certain framework that how you are going to collect the data. It's really cumbersome that because South Delhi have got a different mindset. If you are doing a research on consumer e-commerce, consumer behaviors, I think in that case you can't cater your research to the areas which are below the poverty line. You have to find out the middle class people, or the people who are techno savvy, who are doing the shopping through internet. So that is altogether different ball game. But anyway, the sampling frame talks about the list you use to sample from, and then the sampling error comes. It's very true that when you are making a sample frame, the sampling error comes, and this sample, the ones you ask, and non-response errors comes. That is very true. And now the biggest challenge which is coming up, that is non-response. We make the questionnaires. We know that we develop the questionnaires, and questionnaires is of 3 to 4 pages, which ask the many questions from the respondents, like your name, email, mobile number, or the other details, what you think about the product when you're going to buy the product through online or through e-commerce portal. What impression you have, whether the e-commerce portals are giving you the refund benefits, or they can return the product very easily. So these and sometimes what happen, there no response comes. So when there is no reciprocations, no response comes from the respondents, I think the error used to become. So respondent, the ones who answer, so that are considered to be respondents. Ones who not answer are considered to be the non-respondents. So if you talk about the error, I think in survey research, all deficiencies or weakness are caused by sampling or non-sampling issues. And we have already talked about the sample framework and non-sample framework that engenders the discrepancy between sample value and population value. One thing is very clear, that what exactly we are thinking about, that the population value is there, and then the sample value is there. So this sample value is no doubt varies from this population value and sample value, and we see the discrepancy is terms at error, and although it is explained by several terms. So what we have observed, that the research analysis or statistician explain the terms mistakes, and these mistakes are nothing but are considered to be the synonyms of error, inaccuracies or biasness, because sometimes when we go for the convenient sampling, or we go for the non-probability sampling, there is more chances of biasness, because you try to follow a model which could be quite judgmental in nature. So error is defined as a discrepancy between the observed value, sample statistics value derived from the sample survey, and the expected value, population parameters value, that may occur due to sampling or non-sampling errors. So there are certain key takeaways which we have to take into consideration while going to depth of this sampling errors, because when we get the sampling error or statistical error, we have to analyze and we have to find out that the entire population or data need to be taken care, and how it is going to be taken, because it's really cumbersome, because we have seen at many places that sample circle is population circle is quite bigger, whereas sample circle is very small, but it's considered, are in few numbers. So, and that have a very holistic consideration and from various aspects. So the results found in the sample do not represent the results that would be obtained from the entire population. And that could be the reason. If you are not going to consider the entire population, the reason, and the very best example is that if we have made the Pan India as a base, as a universal or the population, and we are just concentrating on only the 2 states or 3 states, or the 4 states, and we try to get the complete image about the whole Pan India data, I think there must be error, because the data which you are going to collect, the respondents are not from that zone. So sampling error can be reduced by randomizing sample selection, increasing the number of observations what we have, and the best thing is that what I was talking about, that after certain time, after certain intervals, we have to recapitulate ourselves and we have to see that whether the modus operandi or the procedure which we have followed is going in the right direction, or the sampling probability methods, or the random sampling methods we are following, it's good. Otherwise we have to move or switch over into the non-random sampling. So it all depends when you are going to go for it, when you can, or you have an intermingle approach, you can have a the blended model where you can talk about the sampling or this random sampling or non-random sampling on a simultaneous basis. So increase in sample size will reduce these type of errors. That is very true. And in coming slides we can see that how the increase in sample size, but there are certain constants also. If you are going to increase the sample size always, what will happen? The cost is going to involve, the time is factor is going to be enhanced. So somewhere the issue is there. So anyway, if you talk about error, it is going to bifurcate into sample error and non-sampling errors. And when we are going to talk about the non-sampling error, the difference between the sample results and the true population results, that is going to be considered as a non-sampling errors, and these occurs when data are incorrectly collected. For example, if you collected a sample, so non-sampling errors are selection bias, question effects, survey format effects, and interviewer effects, whereas sampling error is non-response bias, transfer of findings, self-selection bias, behavioral consideration is there. So these are the error which is coming up, and there are certain source of non-sampling errors. So non-sampling errors broadly grouped in 3 numbers, that is group A, group B and group C. Group A talks about non-response errors. These non-response, like we have made the questionnaires, we have floated to the respondents, and respondents not reciprocates. So what happened, you have made a sample of 400 or 500, and out of that only 200 had reciprocates. So what is going to happen, that your population is big, and your sample is considered to be from all the zones considered to be 400, but only 100 or 200 have reciprocates. So it means that whatever the results you are going to get, it's not in a total manner come up, and these have a different aspect. So group B error resulting in the stage of data collection of taking observation, that is response error, and group C talks about tabulation errors. Sometimes what happens when we make the questionnaire and send it to the respondents take certain time and then reciprocates with the help of filling the questionnaires. And sometimes what happens, some of the questions need to be filled, some of the questions ignored, or when the questions are ignored, it's considered to be the non-response errors. And when you are going to accumulate all those data, and when you're going to make the response sheet and you're going to make it into a tabulated format, and you find out there are certain questions which still need to be answered, and because if you are not getting a full report of the particular head, so they're considered to be the tabulation error. So these errors result from data processing sometimes, and sometimes the model which I am going to talk about, that is garbage in garbage out model, that is whatever the input you're supposed to put into it, you get the output in that manner. So this is a very important the comparison between the two survey which is taken, and if you go into the backdrop, you will find out that survey A and there survey A and survey B, both the response in one the response rate is low, in survey A, in survey B the response rate is high. But on the other hand, as far as the population is concerned, as far as the survey tool is concerned, as far as inviting the like floating the information to the respondent is somewhat similar, you see. So but when the survey is done, the only it had been floated to 7% people, and when the survey had been done, it had been floated to 30% people. Now you see the difference, what exactly the distinguishment is. The survey A and survey B may have the same number of users. We have seen that all have the same number of users taking the survey, but survey B had a higher response rate because it sent fewer survey invitations. So what we observed, that survey B is less subject to non-response errors because you have sent it to the lot of people, and it's more trustworthy and making results more trustworthy despite having some sample size as a survey A. So what I mean to say that somewhere if you are floating to the more respondents and getting the results, it's somewhat. Now the biggest challenge which comes up, that is type 1 and type 2 errors. What we observe that while going through these statistical errors or the sampling errors, and when we have already talked about, the hypothesis is there, and these hypotheses are considered to be the null hypothesis and alternate hypothesis. So so we start with the null hypothesis on the basis of the objectives, and then when we make the objectives, we have a backup of that, which considered to be the alternate hypothesis. So what we observe that these alternate hypotheses work as a filler. So if any circumstances, if any of the in any situation, the null hypothesis fails, so in that case we accept the alternate hypothesis. So this is one of the reasons that we have bifurcated this whole scenario into type 1 and type 2 error. And in statistical hypothesis testing, a type 1 error is the rejection of true null hypothesis. So we have already talked about the hypothesis in a full-fledged session, which talks about null hypothesis, alternate hypothesis, rejected or accepted or whatever it could be. But here we are just concentrating on type 1 error, which is a rejection of a true null hypothesis, that is whatever the null hypothesis you have considered, and if that null hypothesis is rejected, this is considered to be the type 1 error, and also known as false positive findings or conclusion. So the other nomenclature is there. For example, an innocent person is convicted, so this is considered to be a type 1 error. And when you are going to talk about the type 2 error, is non-rejection of false null hypothesis. So what happened that sometimes you take the null hypothesis with the impression that it is going to be rejected. So in that case, the accepted the hypothesis or the alternate hypothesis are considered to be the type 2 error, and also known as false negative finding or conclusion. So this is very important, because when you are going to talk about the statistical error, it need to be bifurcated into type 1 and type 2 error. So if we see the metrics, I think the metric is quite explanatory in nature. We have reality at one axis, at x-axis, and y-axis, and x-axis we have measured for perceived. So what we have seen that if the reality is true, if the measurement is true, I think we have got a correct notion. And if the reality is false and the measurement is true, I think type 1 error need to be considered, which talks about the false positivity. On the other hand, if reality is false and measurement is false, I think type 2 error comes, and this calls the false negative. So we have seen that null hypothesis is true or reject is true, type 1 error is there. So what I mean to say, that null and alternate hypothesis is a very important thing. Why we keep it? Because when we go for the literature review, when we make objectives, and when we frame the hypothesis on the basis, when we start with this literature review and find certain gaps, and these gaps are going to give us an objectives, and these objectives are going to give us the hypothesis. So what I have told in the very beginning, that when you are going to formulate your objectives could be in your fingertips. It should not be like that. It should be 5, it should be 10 or 20. It must be 5 to 6 or maximum 7, or best is that the optimum is that you can take with 5 null hypothesis, 5 objectives, and convert into a hypothesis. So there must be a 5 null hypothesis and 5 alternate hypothesis. So, and the intention is very clear that if the null hypothesis is rejected, the alternate hypothesis is going to be accepted, or vice versa is there. And if the null hypothesis is accepted, there is no use of alternate hypothesis. So anyway, what we are, and you see this particular image, that we start with the null hypothesis, then perform, and alternate hypothesis also parallelly going on, test outcome accept and test outcome rejected, because your null hypothesis is accepted, so that is very true that alternate hypothesis is going to be rejected. Now the true pass is there, and this is called true fail. So already we have talked about this type 2 error, consume risk, and that is producer risk. So this is where, and if you see, type 1, type 2 error is not detectable, whereas type 1 error is detectable. So this is the model which is there, and once we are in the process of testing the hypothesis, I think we will have a more elaborative sessions which talks about how we are going to test the hypothesis. So in the initial stage, the time is there where we have to build the blocks, and we have to recapitulate ourselves, and we have to build the basics, because there are certain terminologies which are very powerful as far as the research methodology is concerned, as far as the statistical analysis is concerned. So anyway, errors in survey are considered to be the sample error, random error. The level of it is controlled by sample size. A large sample size leads to a smaller sample error. That is very true, because if you have a huge number of sample size representing all the population from underneath to pinnacle from all the domains, not talking about the one domain, but north, south, east, west. So you get a very good your sample results, and there must be a less chances of sampling error, but the error will be there. And this when you are going to talk about the error, because there is a possibility that error will be there, and there will be no foolproof model, that because you are extracting the small portion from the big portion, so margin of error is there, and then there are certain nomenclatures which are coming up, and we will throw a light on all those aspects. So non-sampling error talks about systematic error. The level of it is not controlled by sample size. And now avoiding sampling errors, how to avoid the sampling errors, because it is very true that error is going to come because you are going to extract certain informations and you are not going to get the full pictures, but just taking the glimpse of that. But on the other hand, how you are going to avoid these sampling errors, that is when you are used to conjunction with randomization, samples provide virtually identical characteristics relative to those of the population or product and grouping from which the sample was drawn. So be aware that what three categories of sampling error are there, that is bias, lack of accuracy, dispersion, lack of precision, and non-reproducibility, that is lack of consistency. So these are the things which can help you or navigate you to avoid this. And reducing sampling error is there one way which I am emphasizing from the very beginning, that reduce sampling errors to increase the size of your sample. There are certain the things which is there that you can't, there are certain constraints also. You are not in a position to increase the size of sample after certain intervals, but you have to do, because as I have told that if you have made a sample size of 400 or 500 and the respondent used to reciprocates are 100 in numbers, so in that case whatever the results you are going to get, it's full of statistical error or sampling errors, and in that case you have no choice but to increase your sample. So when the moment you increase your sample or twist your the sample size, I think the cost is going to be involved, the time is going to be more, and other factors which are intangible in nature can also hit you in that case. So that is the reason the literature review, the research methodology or statistical analysis could be done in such a manner that whatever the sample size you have taken, you lead to that particular the number only. So sampling error and sample size have an inversely correlated relationship. That is very true. If you have a more sample size, more size of sample, then there could be a less possibility of sampling errors, and if the sample size grows, sampling error decreases. That is very true. So there must be inversely correlated relationship. So if your sample size is growing in a big number, I think the error is going to be decreases or deteriorated day by day. So it is important to note that increasing sample size usually results in an increase in cost. We have already talked about, and there are two measures that affect the accurateness. I think this is very important, because margin of error tells you how many percentage points your results, because when you're going to talk about the percentage, the level of confidence could be 99%, 95%, 90%, and 99% level is the most conservative, while the 90% level is the least conservative, and the 95% level is the most commonly used phenomena which is going on. And if you see this margin of error, I think estimate and confidence interval is this. So confidence interval starts from margin of error and from left side to right side, and estimate is there. And we have seen that how this confidence level is restricting to 95% level. So if you have a commonly used 95% level, I think you reach to the conclusion. So if the level of confidence which I have talked about, and this 95% confidence level with a 4% margin of error means that your statistics will be within 4% points of the real population value 95% of the time. So now we have to see how this confidence level is interval is going to be controlled, because confidence interval is a range or interval of value used to estimate the true value of the population parameter. So sample statistics, point estimate, then confidence limit lower and confidence limit upper is there. So we have seen that we have taken this the population from various perspectives, starting from the one side to other side to other side. It's not like that we have restricted to the particular sample from one of the areas. So holistically we have taken it, and then the moment we have taken the margin of error is there, statistic plus minus ME, and then 95% is there. So sampling distribution talks about how you are going to calculate statistics for this sample, and standard error is this. So this is basically another way of explaining with the help of the the chart, and you see this whole box, rectangular box, is the population, and the average is, and the midpoint is this. So this is called population mean. We have taken a mean of this whole. This is considered to be a true value. Then sample mean is what, the survey result. So now your sample is somewhat smaller as compared to the population mean, and this is the sample mean of this particular graph, and then 95% probability is there, then margin of error is this, and there is a possibility of 2.5% probability. So anyway, I think we have talked about statistical error, sampling errors, but it's not stopped over here. The moment we take any numerical, the moment we take any real life scenario, we will definitely throw a light and try to talk about that how this difference or how this discrepancy is going to come. So now there are certain questions, FAQs, which are very important. That is the confidence interval the same as the margin of error? The margin of error is how far from the estimate we think the true value might be in either direction. The confidence interval is the estimate, that is plus minus margin of error. Now the other question is, why does the margin of error increase as confidence increases? The margin of error increases as the level of confidence increases, because if we want to be more confident that the interval contains the population mean, then we need to make the interval wider. And number states that the sample size increases, the sample mean approaches. So it's all, it's the genesis behind, the genesis behind this particular thing is that how you're going to enhance the sample size, or the standard format for calculating the sample is there. So sampling error is x bar minus mu. Mu is the symbol of this. So is the difference between the value of sample statistics and the value of the corresponding population parameter. And we assume that the sample is random and non-sampling error has been made. So the mean and standard deviation of the sampling of x bar are called the mean and standard deviation, and which is denoted by mu x bar and sigma x bar respectively. So anyway, I think we have talked a lot about sampling errors, but this is not an end, because when you are going to talk about the statistics, the error is a routine matter. Is a phenomena which used to depict after certain intervals, and there is nothing to become so panic into it. We have to find the solution of that, and the solution is only that as per the circumstances, as per the scenario, we have to twist our research. There must be no rocket science or the thumb rule that you will adhere to the probability sampling, or you will adhere to the stratified random sampling, or but after certain time, if you find out the respondent is not reciprocating, so we have to follow the modus operandi of non-random sampling, which believes in the different kind of methodology like snowball sampling. So snowball sampling is purely based on the reference, and when we have reciprocate to the respondents and respondent reciprocates, we request them to give us some leads, some the references which can work as a chain. So the chain reference model is going to play a very important role, and with the help of chain, we reach to the one people can give a reference of 3 can give a reference of 9 can give a reference of 27. So by this way, the things can be multiplied, and we reach to a very good conclusion. So sampling error is inherent in any sampling process due to the fact that samples are only a subset of total population. I think we have to be quite very clear that we are not exploring the set, but we are exploring the subset. And when we are exploring the subset, I think some of the factors, some of the points need to be ignored. So sampling error depends on the relative size of sample, and these sampling errors can be minimized but not eliminated. So what I mean to say that this sampling error is part and parcel of our research, and there is no question that we have to be embarrassed, because there are certain negative things which become positive or work as an alarm bell, and sampling error is working as an alarm bell. So by this way, we are in the verge of completing this particular chapter, which starts with the sampling, then talking about the sample size, then census, population, and then methods of sampling, and now finally we have conclude ourselves to sampling error. So this sampling error is no doubt work as a driving force and provide us a platform to recapitulate ourselves after certain juncture. So when we have started a research, it's not like that we can follow a monotonous approach or work in a monotony manner. We have to twist ourselves, and we have to follow this SWOT analysis approach or or strength, weakness and opportunity and threat, or certain strategies by which we can twist the things. So it's not like that what we have decided in the very beginning that we will adhere to that. We will have to change our strategy, and then we have to think of what best can be done. So I think by this way we can wind up this particular session, or the particular chapter. The next chapter is going to talk about something more conceptual in nature, and once we build all these concepts as far as statistics is concerned, as far as research methodology is concerned, then we can throw a light on how we are going to apply. And when we are going to talk about the statistics, when we are going to talk about the research, application is very important, and then finally how you're going to implement, and then how you're going to execute. Because if the execution is weak, I think, and these whole process starts with the development life cycle, which starts with analysis and then lead to a conclusion. So we will definitely throw a light on all these terminologies. Thank you very much.